What if your language model could write custom analysis code on the fly, count patterns, calculate statistics, parse timestamps, all in a single pass? RLM with WebAssembly makes this possible. RLM. Level 1 uses built-in DSL commands for simple text operations. The language model selects operations like find, regex, or count. No code generation, just instant pattern matching and line counting. The RLM visualizer lets you run queries on sample data. Here we load a count error lines example with 100 log entries. Clicking Run RLM Query starts the iterative process. The Output tab shows live progress as the language model works through the problem. Each iteration executes DSL commands. First count lines, then regex, but find errors. The language model refines its approach based on intermediate results. Final answer 20 error lines. 3 iterations completed in 7.1 seconds. No code generation required, just DSL pattern matching. RLM. Level 2 uses WebAssembly for complex processing. A coder language model writes Rust code that compiles to WebAssembly and runs in a secure sandbox. MapReduce handles aggregation and statistics on large datasets. Ranking error types by frequency is a common log analysis task. RLM can handle this with custom WebAssembly code. The demo generates 200 log entries and asks RLM to rank the error types from most to least frequent. It found 3 error types. Authentication failed at 60, database error at 40, network timeout at 20 occurrences. RLM compiled custom Rust code to WebAssembly that counted each error type. 2 informations under 17 seconds total. Calculating response time percentiles like P50, P95, and P99 is essential for PI performance monitoring. The demo generates 300 response time entries and queries RLM to calculate percentiles. The median response time is 65 milliseconds. P95 is 733, and P99 is 1837 milliseconds. WebAssembly code extracted numbers, sorted them, and computed percentiles in a secure sandbox. Execution took just 17 milliseconds. Counting unique IP addresses in logs is useful for security analysis and traffic monitoring. 200 log entries are processed. The query asks how many unique IP addresses are in these logs. 8 unique IP addresses were found. Each one appeared exactly 25 times across the log entries. The solution uses WebAssembly to deduplicate values with hash sets. Processing completed in under 10 seconds. Level 2 WebAssembly handles complex analysis. Here we select count unique IP addresses, which uses MapReduce with a unique combiner on 200 log lines. Clicking Run RLM. Query starts iteration 1. The language model analyzes the query and decides to use Rust OBM MapReduce with a unique combiner. The language model writes Rust code to extract IP addresses. This compiles to WebAssembly in about 20 seconds, then executes in the sandbox. 8 unique IP addresses found, 2 iterations in 26 seconds. The timeline shows Step 1 used WebAssembly MapReduce. Step 2 returned the final answer. This example ranks error types by frequency. The language model uses the WASM intent to count and sort error categories from the log data. The language model writes custom Rust code to extract error types from square brackets. WebAssembly compiles in about 10 seconds and executes instantly. Connection timeout leads with 33 occurrences. Request failed has 24. 2 iterations in 16 seconds using low latency net. This example counts HTTP status codes. The language model uses MapReduce with a count combiner to tally each response type. The language model writes Rust code to extract status codes after HTTP/1.1. WebAssembly compiles in about 5 seconds. Status 200 leads with 68 hits. 404 has 22. 2 iterations completed in 10.6 seconds. This example calculated response time percentiles. The language model uses WebAssembly intent because percentiles require sorted data, not MapReduce. The language model writes Rust code to extract millisecond values, sort them, then compute P50, P95, and P99 percentiles. Statistical analysis complete. The median response time is shown along with the 95th and 99th percentiles. 2 iterations in 18 seconds. WebAssembly has trade-offs. No Unicode support, only ASCII. Memory is limited to 64 megabytes, and only a subset of Rust compiles to WebAssembly. These limits enable safe, sandboxed execution. More capability levels are coming. Level 3 uses native Rust CLI for full system access. Level 4 enables recursive language model calls for complex multi-step reasoning. Subscribe for updates. Try RLM now with WebAssembly. Complex analysis in a single iteration. No more manual back and forth. Let the language model write the code it needs. If you found this helpful, please like and subscribe. Hit the bell for notifications, and leave a comment if you have questions. See you in the next one. Bye.